Hi, it has been a while ago that I created a video, so I thought, you know what, let's do something fun again. Today's video will be about this wiki article that I written, I think, 2 weeks ago. And this video just will be a demo of what I've described here. So if you have some time left, please read this article. And it will be about routing with NSX using multiple sites. And in this video, I will explain how to do that with eBGP all the way. So it's good to set a good baseline. So first of all, I've created 2 data centers. Each data center will have its own platform service controller externally, its own vCenter server, and its own NSX manager. And the other side will have the same. And I'm using cross VC NSX. If you log into to one of the vCenter servers, you will see that enhanced link mode is turned on, or it's working, and DC1 has its own vCenter server, DC2 has its own vCenter server. Within the vCenter servers, I have a compute cluster. In the compute cluster, I have 3 hosts, and in the management cluster, I have 3 hosts as well. So I basically have a collapsed compute and edge cluster. For DC2, it's basically the same. In each DC, in the compute, you will see a 3-tier application where I have a Web 1, Web 2, App 1 and 2, and a DB. And in DC2, I have exactly the same. So this translates into this drawing here, where you can see, well, let me just go a little bit up. I just created a routing environment. This is my physical switch. So Cisco 3560, and I have connected 4 virtual routers to that. 2 are in DC1. These are Cisco CSRs 1000 Vs virtual routers, and the other 2 are running in DC2. And I've connected these through interfaces or VLANs to ESGs, and the ESGs basically has 2 uplinks. One is going to router A, and the other one is router A1, and the other one is going to router A2. And for site B, exactly the same. So we have multiple paths. Right now, I just created 1 ESG. I also could have created multiple ones here in ECMP mode, but this lab or this proof of concept is about eBGP routing, and adding more ESGs will probably change the path diversity, but not the concept. So you can see 2 DLRs here, DLR1 and DLR2. In this lab or in this video, we're just going to focus on DLR1 only. And DLR1 is, it has its control VM only in DC1, and the VMs that are connected to it, or logical switches that are connected to it with the VMs, are basically for tenant 1 and tenant 2. Tenant 1 will have a lot of logical switches here, and I will only handle tenant 1 in this video. So as you can see here, tenant 1 has 4 web servers, 4 app servers, and 2 database servers. A part of it is in DC1, and the other part is in DC2. I'm using a universal DLR, so basically the network is stretched across the 2 data centers, and the goal is to have path diversity, but to use the first site, so DC1, as the primary exit path to the outside world. And the outside world I basically defined with a client VM, which is in this subnet here, or this network, 10.11.11.0/24, and this has IP.50. So the goal eventually is, if we do a ping or a trace route from this VM here or this VM here, it should take this path to ESGA, and then either router A or router A1 or A2, and then eventually go to its destination. When we have a VM that is sitting in DC2, so Web 3 or Web 4, it should also take that primary path where we go to ESGA, not B, but A, and then choose one of these two, and then go to its destination. So whenever something happens in this path here, so ESGA goes down or one of these routers here goes down, I mean, if this router goes down, it should pick this one. If this one goes down, it should pick this one. But if both go down, or the ESG goes down, basically it should choose the DC2 path exit in order to reach its destination. So in this video we'll prove that, and I will show you how I've done it. First of all, let's go back. Let's look at the NSX settings to have a good understanding. Network and security, yes. Let's go to the dashboard, and in the dashboard you will see you'll see a good overview of what's happening. So you can see that I have, the primary NSX manager and the secondary NSX manager. Right now I focused on the primary NSX manager, which is obviously in DC1, and you can see that everything's green. Well, there are some things that I have not configured, and there are some clusters that I haven't prepared, which is basically the management cluster, which is not needed to prepare for this lab. So everything looks good here. Let's go to the secondary. And again, everything's green. If I go to logical switches, let's go to logical switches. No, let's go to installation first, where I can show some of the. Here you can see again that I have two NSX managers and universal controllers deployed. My host preparation went fine. As you can see, I've only prepared the compute. The compute exists of 3 hosts. This is the secondary. Let's go to the primary. Also everything fine. Logical network preparation. Only compute is configured. And segment ID configured, universal pool as well. And I only defined like one global or universal transport zone, where I have 12 logical switches. Let's go to logical switches. And here you can see my logical switches for tenant 1, web app and DB, for tenant 2, for tenant 3. We're only going to handle tenant 1 now, and the transit logical switches. Now, in terms of the edges, where it becomes a little bit more interesting, if you look at the drawing, you can see that I have ESGA and ESGB. ESGA is supposed to be on NSX Manager 1, and ESGB is supposed to be NSX Manager 2, so the secondary one. Let's verify that. So as you can see here, primary ESGA region A is now here deployed, and ESGB is here deployed region B. Let's go back. You can see the UDLR, which is deployed, and on the second side it should be active, and it is active. So let's look at the settings. Let's first go to the settings of the universal DLR, universal DLR 1, which is in, I think it's a little bit hard to read here, but I'm going to read it for you. It's AS65530, and these ESGs are in different ASs, and also these routers are in different ASs. So that means that it pairs with eBGP. So from the DLR to the ESGs, all eBGP, and from the ESGs to the routers, also eBGP, and from the CSRs or the routers to my physical switch to connect everything with each other, it's also eBGP. So eBGP all the way. Let's go back and look at the settings. So let's first look at the UDLR. And in the UDLR, you will see that I have disabled the firewall. Should be disabled the firewall because we're using it in eCMP mode. So I disabled the firewall. In terms of routing, let's go to the global configuration first. eCMP is enabled. I do not have a local ID because I'm not using that feature at the moment. I don't have a default gateway because I want to depend on routing. I set the router ID, I enabled BGP, and that's it for now for the global configuration. Then I have some BGP settings here where BGP is enabled. I set the local AS. This is very important that graceful restart should be disabled. So that's also disabled. And I define the peers here. So notice that I defined two peers. And basically this UDLR, which is this device here, pairs with ESGA and it pairs with ESGB. And I'm using the IP addresses, of course, to pair with it. Using the protocol IP addresses here. So you can see that, let me check. Yeah, here. It's 172.3939.1 and 172.3939.2. If we go back to the drawing, we can see the black line here. It's .1 and .2. 172.3939.2 and .1. 1 is ESGA DC1 and 2 is ESGB DC2. That looks good, right? Notice that I also specified the remote ASs. So DC1 ESG is 65521 and DC2 ESG is 65522. The weight is also different because I want to prefer the DC1 path. That means that with BGP you can set the weight, and the highest or the higher the weight, the more preferred the path is, and it will take that. So this is the DLR configuration. Now let me look at the router distribution, because I also have some connected routes, which are basically my logical switches, which I want to redistribute into BGP to make sure that my logical switch networks are known to the rest of the world. And here I basically said, okay, all connected routes can or are allowed to go into BGP. So let's go back. And let's go back to the ESG actually, or both of the ESGs, to see the settings there. And these settings and how I've been doing it, it's all described here in this blog post. So you can see some screenshots, what I've been doing, the steps, some screenshots, exactly how I've done it. So let's go check the ESGA DC1. And again, routing, global configuration, the firewall, I disabled the firewall, of course. Routing, eCMP is enabled. Default gateway, I disabled that. Set the router ID, enable BGP. Go to the BGP settings where I basically specified local AS, and I have 3 peers right now here, and that's correct because if you go to the drawing again, you can see I have to pair with the first CSR, the second CSR, and I have to pair with my DLR from this DC1 ESG point of view. And as you can see that it's all done. Let's go to the second ESG to show you these settings as well. Secondary, and again firewall was disabled. Routing, let's go to the global configuration, eCMP enabled. Router ID is set, BGP is enabled. default gateway is cleared. And again, the local AS, which is the different one, with 3 peers again. If you look at the drawing again, it has to pair with this, with the DC2 CSRs, but also with the DLR, which all looks fine. So in order to verify this, we can log in to these devices and look at the peers. Well, you can see that my prepared sessions are timed out. So let's first log into the DLR. And if I do a show IPBGP neighbor, I should be able to see that all of the neighbors are established and up. So here you see one of them, again established and up. And the third one, oh, that was the third one. Let me see if I can go up. Oh, I can't. Oh no, it's not the third one. This UDR only has 2 peers, of course, obviously. So they're both up and established. And you can see that some of my prefixes here are received and sent, which is good. So let's do a verification, and verification is very important. Some people believe that I'm not capable of doing that, but let's keep my private issues aside. Restart session, admin. Let's log in again. Oh, wrong password. So we are now going to verify the BGP peers from, let me get the drawing again to make it a little bit more clear. Yeah, we're now logged into this device here, the RTA01, and that has 3 BGP peerings. No, 2. It should have 2 actually. Yeah, it should have 2 because it's pairing with my physical switch and my ESG here. So let's have a look on there to see if those show IPBGP. Well, and you can see here that the up down is almost 2 weeks, 1 week here for this one here, which is fine. So you can see this output here that works. You can also do I now looked at the summary. If I do a show IPGP neighbor, there are a lot of details where you can basically see that the state is established and up. And for the other peer, I mean, there's a lot of information. You can, for the other peer, it should also be established and up. Well, a lot of information that we're not doing or that we're not using at the moment. Here you can see established and up again. So that's why I kind of like to use the summary command, because I only want to know if it's up or not. And you can see I have 2 peers which are up. One for 2 weeks, one for 1 week. And 6 days. Let's log into the other one of DC1. Let's restart the session again. Show IPBGP. Oh. There you go. And again, 2 pairings up. I haven't paired with each other because I didn't thought that was needed. Let's go to side B, so DC2. Show IPBGP summary. Again, both pairs are up. And the second router of DC2 There you go. Also both up. I think it's good to also do a verification from the ESG side. So let's go. I already logged into ESG. Show IPBGP neighbors. And here you can see that this neighbor is established and up. This one is established and up as well. Let's go a little bit down. This one is established up as well. Let's go to the second side, ESG. Show IP BGP neighbors. Again, established up, and established up. So we've done the peering verification, and we know that BGP at least is supposed to work. I mean, the peerings are there, and from there, this is a good starting point. Now it's important to look at the tables, the BGP table. So if the BGP peers are there, and the let's go back to the drawing, and if the logical switch networks here are redistributed into BGP, and of course this network here is redistributed into BGP as well, then I mean, communication should be possible. So how do we know if the networks are distributed? I think it's a very simple test. We just go look at the routing tables, and the routing tables we can, I mean, if we go end to end, the DLR, I think you should agree with me that the DLR here should have this route here of this network, the 10.11.11.0, in order to reach this client VM or this outside world VM. And this router here, or basically all routers here, virtual routers, should contain these networks here. The 172.20.0, the 172.20.2, sorry, made a mistake here, 172.20.1 and 172.20.2, and the 172.20.3 networks, which is still web, app, and database. So these networks should be available on these routers here, because otherwise routing is not possible. So let's do a quick check then. Let's start with the UDLR. I'm not going to log into each device and look at the routing tables, because I mean, if you go into this article here, I have already done that in a very detailed manner, and the configurations are also there. So let's go back. Show IP route BGP. Let's do that. And here you can see my BGP routes that I've received. And I think the most important one is the 10.11.11.0 is here. You can see it here. And it's learned through ESG1. It's learned through 301. Yeah, ESG1. Yes, correct. So let's go back to the routers, and let's do an IP route verification there as well. Show. Oh wait, what you can also see here is if you do a normal show IP route connected, you can see all the connected routes. And for us, which is only relevant is the first top 3. These networks should be visible on these routers here. So for the show IP route BGP, you should be able to see that it has been learned through BGP, and here you can see it. Let's do a verification here as well. Show IP route BGP to make it a little bit more readable. And here you can see them as well. To the site 2 routers, show IP route BGP. There you go. Also these 3 routes here And let's go to the second router of site 2, DC2, show IP route BGP. And here you have them again. So that means that communication is possible. So, I mean, what path is it taking? So if you want to see the path information and you can probably go a little bit deeper, which I won't do right now, which I have done in the article. But let's do, for example, one show IP BGP. So here you can see some more information. Right now, I am going to look at the DLR first, show IP BGP. And what's important is to look at the weight of the routes, and you can see the weight here is all set to 200 here. Where's my mouse? Ah, here. It's all set to 200 here. And I think if we do so the goal now is to verify the path. Let's go back to the drawing. And what I've told you before in the beginning is that I want to have Web 1, Web 2, Web 3, and Web 4, and basically all VMs, use the primary path, and the primary path is the DC1 ESGA to reach this VM here. And this VM is just in the outside world. It isn't specifically on DC1 or DC2, it's just the outside world. So let's verify that. I am already logged into this terminal server or this hop-on machine is basically this client VM. So yeah, I can prove that by just doing ipconfig, and you can see that it's 10.11.11.50 here. So what I'm going to do right now is I'm going to what's the best way to do this? Yeah, you know what? I'm going to log into this web server here, which is Web 1, and I'm going to log into Web 3. And these two webs I'm going to use as my example. I use more examples in the article, but I mean, for now it's only relevant to just show one. Let's go to Web 1. What was the password again? Log into Web 1, and let's go to Web 3, which is in DC2. Admin, no, root. So I have Web 1 and Web 2 here now. Well, you can see here that it says Web 1 here, but I mean, I was too lazy to change the host name. I did some cloning, I did some predefined deploying. So, but again, if you go look at the IP address, this IP address here has the IP address, where are you, of 172.20.1.1, and here show, no, not show, it's not a router, IPA, this one has the IP address 172.20.1.3. And if you go to the vCenters, you can see here that my Web 1 is here in DC1, and my other Web 3, I actually did rename it here, is running on DC2. Okay, just to prove that I'm not bullshitting around. Okay, so let's do a trace route from Web 1 to this machine here. So again, trace route 10.11.11.50. There you go. let's do the same here as well. Trace route 10.11.11.50. So this one is finished here, and you can see that the path that it has taken, it goes to its default gateway, which is the DLR. Then from DLR, it will go to the ESG, the first one. See, 172.39.39.1, and then it will go to the 10.100.21, which is this 100 indicates that it's taking DC1 as the path, and then it will find its destination. And if we go to the second side, so DC2, you can see that it's taken its default gateway, then it goes to the first ESG, so DC1, and then it will take the other router on DC1 as well. The 100 indicates that it goes through DC1, and in DC2 I use 200, and my mother-in-law decided to clean up the living room. So if you hear a vacuum cleaner, sorry about that. But anyway, I will continue. Let me see. Yeah, so I mean, these two trace routes basically proved that the first path has been taken. So what we're going to do right now, we can also test it the other way around, by the way. So let's go, and this is my VM, my external VM. Let's go and so if we do a trace cert from this machine here to the web servers, which is 2.20.1.1. Let's see what path is, and you can see here that it's taking from the outside world, it's taking the first path as well. Let's go to the other, the DC2, web 3, 3. Again, you see that it's taking the DC1 path. So let's break the DC1 path, and we can break the DC1 path on multiple ways. I will only shut down the ESG here, because I mean the other paths with router A and router 2 shut down. I already tested that in the article as well. But we want to break the path, the full path here, to see that the traffic is now that the traffic will go to a true ESGB through the second site, DC2. So the only thing I have to do is either, kill these two or kill this one here, the ESG. I will go for the ESG. ESGA, which is this one here. And what I will be doing is I will power it off. So ESG powered off. Yes, I'm sure. And it's powered off. So that means that my session should also not work anymore. My SSH session that I had to that ESG. Where is it? So many sessions open. I think it's this one. Yeah. not working anymore. My region B, so my second ESG is still working. This one is down. So let's do the trace routes again. And let's open web 1 and web 3 again. And you can see that these sessions are not working anymore. So I probably need to reconnect. And if I'm reconnecting, let's do it the other way around again. So let's go to traceroute 1. Yes, there you go. Probably takes a while for routing to kick in, so let's wait for this amount of time. Because I haven't really used very aggressive timers, which was, out of scope for this lab, I guess. So it will use the default timers, default hole and dead timers. So it will take a while in order to discover that the ESG is not there anymore and that it should take another path. And it probably didn't now at this point. So let's do my traceroute again. There you go, and you can see the 200 here, right? 200 is DC2. Let's do it for the other workload as well, my web 3. And there you can see it used the second side as well. So this is a test from my client VM towards my web servers. Now let's go from the web servers, close the web servers. So I need to log in again. And you can see I can reach them again. Root. Nope. Don't want to open iTunes. Root. And yes, this is the 3. And this is the 1. So let's do traceroute to 50 again. And here also traceroute to 50 again. And it should take the second path. And here you can see that based on the 200 here, 10.200.19, it's taking the second path. Let's do one more test and bring the ESGA back up again. Let's power it on. And my expectation actually was with this that, when routing kicks in and everything does its thing in the proper way, that the first site should be primary again. For some reason, this doesn't really happen. I cannot explain why, and I'm still investigating that. Yeah, so I mean, in order to make the primary site primary again, I found like a manual workaround, which is, I mean, not that clean because you actually want to have it automatically, just to switch over. But right now, I just need to have manually. But I mean, in case of a disaster, or if your site 1 goes down, at least site 2 takes over, and you will not have any downtime. Or, well, with the timers that I have, you will have some downtime, but not that much. If you set the timers more aggressive, then the downtime will be less. And the flip over will also be more seamless then. But now with a manual intervention. So right now, let's see. Let's go to the ESGA. We can open the console very quick. Yeah, it's there. It's up and running again. So let's see if we can set up a session to it. Wrong password. Yeah, and it's back. So right now the expectation would be, let me go back to my web servers, that the primary path should be taken again. Well, tested this, doesn't work. So I can assure you that right now, if I do a traceroute to my outside world VM, it will still take the DC2 path. Yeah, you can see that here, 200, even though that the ESGA is up and running again. So there are two ways that I can fix this. I either reboot or shut down the ESGB here, or I just go to settings and go to the edges and go to my ESGB. Secondary is already selected, and what I do is I edit, I disable BGP here, okay, publish, wait for a few seconds, and then edit, enable BGP again. Wait for a few seconds. Let's go to the web servers. Do another traceroute. Could be that BGP still needs to do its thing, so we may need to wait a minute, but let's see what it does. And you can see that it's back on, well, DC1, on the DC1 path with the 100. So with this video, I basically demonstrated the different paths using eBGP. In my next video, I will probably demonstrate it using iBGP, which will, well, I think the expectation will be the same. What I will do is I will make sure that these ESGs here are in the same AS as the DLR, and that means that the connection will be an iBGP connection from the DLR's point of view and the ESG's point of view towards the DLRs, but from the ESGs towards the CSRs it will still be an eBGP connection. Yeah, thank you for watching and have a good day.